Hey everybody, this is Mr. Beckstrom, and today I'm looking at an example from section 7.5, and it says if the sine of theta is equal to 9/10 and theta is in quadrant 2, find the exact value of the following here. And they give us the cosine of theta, the sine of theta plus pi over 6, the cosine of theta minus pi over 3, and the tangent of theta plus pi over 4. All right, so let's go ahead and get started here. Um, now, this first one right here, we're just going to basically use the Pythagorean identity for that. So that one's going to be pretty easy here. All right, so we know that for A is, I have to use a mouse for this. So I know the sine squared of theta plus the cosine squared of theta is equal to 1. So 9 over 10 squared plus cosine squared of theta is equal to 1. So we can just really solve for the cosine of theta. So cosine squared of theta is equal to 1. I'm going to go ahead and write 1 as, let's go ahead and write that as 100 over 100, and we'll see why in just a second. 100 over 100. This becomes, if you square that, that's going to be 81 over 100, and then I'm going to subtract it from both sides, so this will be minus 81 over 100. All right, so notice I just squared this out and then I subtracted that from both sides. So cosine squared of theta is going to be equal to 100 minus 81 is 19. So that's going to be 19 over 100. Take the square root of both sides, and we're going to get the cosine of theta is equal to plus or minus. This is going to be the square root of 19 over the square root of 10, which is just 10. And since we are in quadrant 2, that's on the left side, that's where the cosine is negative. So it's just going to be the negative version of that. So that's just going to be negative square root of 19 all over 10. So we just set it up just like that. And we could also have done this by doing triangles. And let's go ahead and do that as well, just to see how that would have worked out. So if I would have done this in the second quadrant here, made a triangle using the x-axis, I have my angle here. Sine is opposite over hypotenuse, so that would have been 9 over 10. And then I would have had to find this side using the Pythagorean theorem, which would have been a squared plus b squared is equal to c squared. So we would have had 100 minus 81, which would have been 19. So this side would have been the square root of 19. Notice some of the same math that we're using. And then to find the cosine of this, it would have been adjacent over hypotenuse, and it's negative since we're in that, so we would have gotten the same answer there. So I could have either used the Pythagorean identity, or I could have set up triangles and then used the fact that we were in the second quadrant. So either one of those would have been fine. All right, so let's go ahead and take a look at the other three. Now for the other three, it looks like we're going to have to use sum and difference formulas for the corresponding trig functions. So for sine, we have a sum formula for sine. So that one looks like this. For the sum formula for sine, it says the sine of sum a plus b. And this is going to be on page 493 of your book. That's equal to the sine of a times the cosine of b. So this is b here, times the cosine, oops, let me, sorry, I said it right. I wrote it wrong. Sine of A cosine of B plus the cosine of A times the sine of B. Did that again. Cosine of A times the sine of B. All right, so here's the formula for it. So here our A is theta and our B is pi over 6. So let's go ahead and write this out. So this is the sine of, and our theta is 9/10, right? So, or, yeah, so this is sine of 9, or let's just write sine of theta times the cosine of, here's our B, right? Times the cosine of pi over 6 plus the cosine of theta times the sine of B times the sine of pi over 6. And excuse my writing. All right, so this is equal to, we know the sine of theta is 9/10. The cosine of pi over 6, if you look at your unit circle, we should know that that's the x value at the pi over 6 angle, so that's root 3/2, square root of 3/2. All right, and plus the cosine of theta. So the cosine of theta is this, so that's actually going to be a minus square root of 19/10 times the sine of pi over 6. So that's the y value there at the pi over 6, the 30-degree angle. So that will be 1/2. All right, and then we just really have to combine. So this is going to equal oh. All right, this is going slow. There we go. 9√3 all over 20 minus square root of 19 all over 20, which is equal to 9√3 minus root 19 all over 20. Woo! All right. So that's the second one. Now the third one, I'm going to let you guys go ahead and do. You just need to know the cosine sum and difference formula, or for that one, the difference formula. So let me go ahead and write that one out for you. Let me give myself a little bit of space here. So for C, we're going to have the cosine difference formula. So the cosine of A minus B, well, that's just going to be equal to the cosine of A times the cosine of B. Now for cosine, the signs here are not going to match. So if this is a minus here, this is actually a plus. For sines, they match, but for cosines, they don't. Plus the sine of A times the sine of B. All right. So for this one, you're just going to have the cosine of theta times the cosine of pi over 3 plus the sine of theta times the sine of pi over 3. And then you're going to end up doing the same thing like we did before and see what you get over there. So try that out and let me know how that goes. And let's go, and it's a extremely similar process to what we just did here with the sine. So I don't think we need to go through that one. So I'll leave that one as a self-exercise. Well, let's go ahead and do the D together because that was a little bit different here. So D is the tangent one, and even though it's a bit of a similar one, it's going to be a little bit more complicated. So the tangent one here says, and this is the tangent of the sum, so it's a sum formula. So the tangent of a plus b is equal to, and I'm on page 495, is equal to the tangent of a plus the tangent of b all over 1 minus the tangent of a times the tangent of b. All right, so in order to kind of figure this one out here, we need to know what is the tangent of A and what is the tangent of B. Well, A is our theta and B is our pi over 4. So let's go ahead and write this out. So this is going to be equal to the tangent of theta plus the tangent of pi over 4 all over 1 minus the tangent of theta times the tangent of pi over 4. All right, well, you might say to me, well, what is the tangent of theta? Well, the tangent of theta should, by definition, just be equal to, so the tangent of theta, and we're going to do that a little bit separately here. Let's actually do that off to the side a little bit here. We'll do it over here so we don't really kind of get in the way of our equation. So the tangent of theta is equal to the sine of theta, right? Divided by the cosine of theta, right? By definition, which is equal to, well, let's go back up here, and we already know what these are equal to, right? The sine of theta is 9/10, and so the sine of theta is 9 over 10, and the cosine of theta is negative square root of 19 over 10. Negative square root of 19 over 10 is negative square root of 19 over 10. All right, so let's go ahead and simplify this a little bit. So that's equal to, if we're going to multiply by the reciprocal of the denominator times, that's a negative, 10 over the square root of 19. So those will cancel out, and I'm left with a negative 9 over the square root of 19. Now, if I were to just go back up to my triangle up here, we are in the second quadrant where the tangent is negative and the tangent is opposite over adjacent. So could have also figured it out that way. The answer to that is yes. So this was just kind of a long way to do that. I could have just used my triangle up here as well. But I want to show you multiple ways to do the same thing. And this is also a good check as well. All right, so we have that. So now we also need to know, well, what is the tangent of pi over 4? So the tangent of pi over 4, let's go ahead and figure that out here. So if we look at the angle of pi over 4, that's going to be equal to the sine of pi over 4 all over the cosine of pi over 4. Let's go ahead and just do this in our calculator here. We haven't been using our calculator very much. Let's make sure I am in radians, which I am not. And let's just do, we already know that this is equal to 1, right? Because it's root 2 over 2 divided by root 2 over 2. But let's go ahead and just verify that. So second pi divided by 4. And sure enough, that's equal to 1. So that is equal to 1. All right, so now I just have to replace the tangent of theta with this value and the tangent of pi over 4 with that value. So this is going to be equal to negative 9 over the square root of 19, replacing that, plus 1 all over 1 minus, and then this is negative 9 over root 19, right, times 1. So it's going to look something like that. And then the last thing we really just need to do is kind of clean this up as much as possible. So what I can do here is, and that's the last thing I'm going to work on, is try to make this, I'm going to combine the two terms on the top and the two terms on the bottom. And then, so let's see what we can do here. So on the top, this is negative 9 over root 19 plus, and I'm going to turn the 1 into root 19 over root 19. And then on the bottom, I'm going to do this as root 19 over root 19. The two negatives cancel out, and this is just 1 times that. So this is going to be plus root 19 over root 19. All right, and then I'm going to kind of go over here. So this is equal to, and this, the top here is going to be root 19 minus 9 over root 19 all over, and this is 2 root 19s, so let me just make sure. Oh, wait, I'm sorry. This, I messed up there, didn't I? On the bottom here, this root 19 and root 19 plus, that's 9 over there. I was not paying attention, was I? Plus, and that should be root 19 plus 9, root 19 plus 9, all over root 19. All right. Now I'm going to go ahead and multiply the top by the reciprocal of the bottom. So this is going to be root 19 minus 9 over root 19 times root 19 on top, all over root 19 plus 9. And those will cancel out. And I'm finally just left with root 19 minus 9 all over root 19 plus 9. And this might actually, if you wanted to rationalize the denominator, you could. But that might actually be kind of a funny one to do. But that's probably fine just like that. All right. If you have any questions, let me know. I know this is kind of a long video, but I definitely wanted to go through some of the processes there. All right. I hope you all have a great week. I know we just had a test this week. That's why we only had one section, but I hope everything goes good. Thanks. Bye.